In this problem, we're given a graph and we're either meant to find a path that has a length of at least the ceiling of n by 2, or we're meant to pair at least the ceiling of n by 2 nodes such that for each pair of pairs, the number of edges in the induced subgraph formed from them doesn't exceed 2. Let's first build a DFS tree on the given graph. The red edges are back edges. If the maximum depth of a node is greater than or equal to the ceiling of n by 2, we've found a path. Just output all nodes from the root to a node at maximum depth. In this example, the maximum depth is 5 at node 10, so we can output a path from node 1 to node 10. If the maximum depth is less than the ceiling of n by 2, let's show that a valid pairing exists. At each depth in our DFS tree, keep pairing nodes of the same depth till either 0 or 1 node remains. The maximum depth of our tree is less than or equal to the floor of n by 2, and because each depth will have at most 1 node remaining, we will have at most floor of n by 2 nodes remaining in total. N minus floor of n by 2 is equal to the ceiling of n by 2. Hence, this method always pairs at least the ceiling of n by 2 nodes. Now let's take a look at our DFS tree. Since it's an undirected graph, we only have tree edges and back edges. Cross edges aren't possible. Let's analyze a random pair of pairs. Let's take 6 and 7 and 2 and 3. We obviously can't have an edge between nodes of the same pair as they'd end up being cross edges. Now the pair that consists of 6 and 7 is at a depth that's lower than the pair consisting of 2 and 3. Since only edges back to an ancestor are possible in this graph, the observation out here is that at any one depth, an individual node can have at most one ancestor at a particular depth. As a result, all pair of pairs have at most 2 edges. So nodes 6 and 7 can have a back edge to only one of the nodes at depth 2 each. Hence the subgraph has at most 2 edges. In this case, there's just one edge as there's only a back edge from 7 leading back to 2. To look at this more simply, let's analyze a different pair. Suppose a valid pairing resulted in the pairs 7 and 8 and 2 and 3. In this graph, 2 is an ancestor of 7 at a depth of 2 and 3 is an ancestor of 8 at a depth of 2. We have a back edge from 7 to 2, but we can't have an edge from 7 to 3 as that'd end up being a cross edge as 7's ancestor at depth 2 is node 2. Similarly, node 8 has a back edge up to node 3, but no cross edge up to node 2, as node 8's ancestor at depth 2 is node 3. So I'll reiterate the solution once again. First, build a DFS tree. If the maximum depth of any node is greater than or equal to the ceiling of n by 2, output a path from the root to that node. Otherwise, at each depth of the DFS tree, keep pairing nodes till there's either 0 or 1 node left. This is a valid pairing. So that's how you solve problem E. I hope that was helpful. I have video editorials for A, B, C and D too, so if you're interested, please check them out. If you found this helpful, please subscribe to my channel. I'm not quite sure what kinds of videos I'm going to make yet, but I do think that 3 Blue 1 Brown style competitive programming videos would be helpful. Please like, share and comment, and feel free to share any suggestions that you might have.